Okay, so in this video, what we're going to do is we're going to verify the differentiation formula for the natural exponential. So let's say we have y equals e to the x. So what we're going to do is we're going to use implicit differentiation to show that, to basically derive the differentiation formula for e to the x. Okay, so what we're going to do is we're going to take the derivative of both sides. We're going to take the natural log of both sides. Right, so that's what we have. And now we're going to take the derivative of both sides in this case. So we're going to take the derivative with respect to x of the natural log of y, and then we're going to take the same thing over here. Right? So far so good? Okay. So now what happens here? Well, this side is going to be implicit. So this means that I'm going to take this function of y, so the inside function is y. So the derivative of the inside function is just going to be dy dx, and then the derivative of the outside function is going to be 1 over y. So we're going to get 1 over y dy dx, and this is going to give us 1. And so now if we solve for dy dx, we find that dy dx just equals y. And there you got it. So we just showed that the derivative of y with respect to x just gives us y. And so that shows that we get e to the x back out. So this basically gives it to us right here, because we find that dy dx equals e to the x. What is this? What is dy? E to the x. Okay, so now that means what happens when we integrate? Well, all we're going to do is we're going to get the same thing, except a difference of a constant, right? So now that gives us the integration formula. So that means that when we integrate e to the x, we're going to get e to the x plus some constant. And so let's do some examples.